Hey everyone, Mr. Strider here. So today we're going to talk about how to use the quadratic formula to solve a quadratic. And again, just like factoring or completing a square, the quadratic formula is just another way to solve a quadratic for its x-intercepts. So what is a quadratic formula? The quadratic formula is this beautiful looking expression here. So negative b plus or minus the square root of b squared minus 4ac all over 2a. So the only things that we need to know to solve the quadratic formula are the a, the b, and the c value of a quadratic. Now, the a value, the b value, and the c value are all within standard form of a quadratic. So right below this, I'm going to write ax squared plus bx plus c, and this would be the standard form of a quadratic. So I just need to match up the numbers that are in front of the x squared, the x, and then also the constant at the end. So that's going to be the first thing I do. I'm going to find my a, my b, and my c. So over here on the side, my a value, my a equals 5. The number that's in front of x squared. My b value is going to be the number in front of x, so 12. And then my c value is going to be the constant at the end, or 4. Oops, smudged that a little bit. 4. Now, all I'm going to do is I'm going to take these three values, substitute them into the formula, and I'm going to simplify to get my solution. So, whenever you see negative b, just think of the opposite of the b value that you have. So if I have a 12 here, it's going to become negative 12. Now, if I had a negative 12, it would then become positive 12. So I always tell my students to think of the opposite because that can sometimes be a little easier to think of than like negative 12, which would become positive 12. So that can help a little bit. So here, when I plug this in, it's going to be negative 12 plus or minus the square root of b squared, so 12 squared minus 4 times my a value, so 5 times my c value of 4. So that's what we have so far. And then in the bottom, this is all over 2 times my a, or 5. So now that I've got all my numbers substituted in, I'm then going to simplify and reduce this down as far as I can, and I'm going to end up with two answers, one that's plus this and one that's minus this. So I'm going to leave the negative 12 for now. And I'm going to simplify what I have here. Radical. Just a tad so y'all can see this a little better down here. So 12 squared, 12 times 12 is 144 minus 4 times 5 or 20. 20 times 4, 80. So 144 minus 80 all over 2 times 5 or 10. From there, I'm going to keep simplifying. I'm going to keep going inside the radical. 144 minus 80. So I'm going to have negative 12 still, plus or minus the square root of 144 minus 80. So 84, 64. All over 10. All right. So then I'm going to ask myself, okay, is this a perfect square? In this case, yes. So the square root of 64, it's going to be 8 over 10 8 over 10. And then now I'm going to split this into two separate expressions, one where I'm adding 8, one where I'm subtracting 8. So the first one I have is negative 12 plus 8. That's going to be negative 4 over 10. Well, negative 4 over 10 will simplify to negative 2 fifths. Negative 2 fifths. So negative 2 fifths. Not sure why that's not focusing over there, but this is negative 2 fifths. And over here I got negative 12 minus 8, or negative 20 over 10, which will simplify to negative 2. So my two solutions to this problem are negative 2 fifths as well as negative 2. So if you found this video useful, please let me know. And I look forward to seeing you guys in the next video. Mr. Strider out.